Hello everyone, my name is Martin Linksfeld and I'm Master Chef in FoggyKitchen.com. In this video, I would like to mix a bit of theory and practice. Frankly speaking, this video has been inspired by my recent discussions with channel subscribers. Yes, it's true, in my course there is no introduction video, so now I'm trying to fix it. I will try to talk about infrastructure as code concept and then about implementation of this concept in practice with Terraform and Oracle Cloud Infrastructure. One more thing. If you are new to this channel, I really encourage you to subscribe it. I hope you'll find it useful for your current and future work. What is infrastructure as code? What is the sense of this concept? Let's take a look at what we can find about it in Wikipedia. We can read there that infrastructure as code, in short EAC, is a modern process of managing and provisioning computing infrastructure. It could be a network, virtual machine, or even software component. What makes a big difference with infrastructure as code in everyday life of DBA or sysadmin? With this practical mindset, we rather prepare some definitions file instead of physically configure the hardware or installing the software in interactive mode. Definition files are treated as code, so as the code could be stored in some version control systems. Every change you make to the code will be registered as a new version. All of that was also possible in the past with the use of the script or some declarative approaches. The advantage of new approach lays in a strict control of what we had in the past now and what we plan to implement in the future. And there is no need for different types of documentation. You look into the code and you know what is there. When exploring infrastructure as code concept, we have talked a little bit about theory, right? Now let's examine how Terraform utility could turn that theory into everyday practice. First of all, what is Terraform? Terraform has been developed as an open source solution by HashiCorp company. Initially released on GitHub in 2014, Terraform has been quickly adopted by the cloud community. Currently on GitHub, Terraform's code has more than 1,000 of contributors with more than 20,000 of commits and more than 100 releases. Open architecture makes this tool very elastic and simple as well. As a consequence, Terraform can be used for managing popular cloud service providers as well as custom in-house solutions. On the other hand, it scales up according to our growing needs. So, it can run for a single server and application, or you can code your entire data center with dozens of networks, virtual or bare metal machines, application servers, databases, or any other components. Terraform is based on graph theory, part of the mathematics where mathematical structures are used to model pairwise relations between objects. Terraform code written by the developer is translated into execution plan, which describes what execution will do to reach the desired state of infrastructure. With Terraform Graph, you will see the workflow and all of the dependencies will build execution pipeline. Some resources will be built after the others. The sequence could be controlled by the code, as well as some parts are strictly related to the cloud provider constraints. Terraform stores current state of the cloud entities and resources within Terraform state files. During the planning and the execution phases, Terraform compares the Terraform state files and the real status of the resources exposed by REST APIs. As a result, state files are updated and Terraform is aware of the results of the changes after every single execution. It will be then used as a foundation for future changes. All of that helps Terraform utility to create incremental execution plans which can be then applied. We can call this tool somehow intelligent, which especially is useful with big cloud infrastructures. One more slide about Terraform in the newest version 0.12. As I have mentioned before, Terraform is very lightweight. It is written in Golang language. In practice, you will download one binary file from GitHub service or directly from website terraform.io. On the other hand, you can pick up the source code from GitHub repo and refactor it for your own purposes. Binary runtime is available for the platforms such as macOS, FreeBSD, Linux, OpenBSD, Solaris, Windows, and the others. You can expect constant changes and new releases. Within last quarter, we have noticed very fast deployment, one release per month or even more. For coding the configuration files, you should learn HCL, HashiCorp configuration language, which is very similar to JSON syntax. As we have described before, Terraform could be enriched with a lot of extension and plugins called providers, which helps to integrate well with existing tools such as Chef technology, for example. Let's focus for a moment on Terraform providers. As I have mentioned before, it is a crucial part of the extensible architecture which lays in the heart of Terraform core technology. Terraform providers included in Terraform binary or configured as an additional module plugin are responsible for understanding REST API interactions and exposing cloud resources to the code. For a present time, providers support infrastructure as service such as Oracle Cloud Infrastructure, Amazon Web Services, Google Cloud Platform, or Microsoft Azure. In a platform as a service domain, you can find providers for Heroku or Oracle PSM. Terraform providers support also software as a service, for example, Terraform Enterprise, DNS Simple, or Cloudflare. On the current slide, on the right side, you can notice some example of OCI provider configuration. For the purpose of the configuration, you need to provide some fundamental and obligatory OCI tenancy attributes such as region, tenancy OCID, user OCID fingerprint, and path to the private key. All of that could be then used to access the tenancy and let Terraform automate your infrastructure. In this particular example, you have two instances of the provider, one per OCI region, which helps you to control the automation even in a distant location of your cloud infrastructure. It could be, for example, very useful for disaster recovery scenario when one location could fail over to another location. Please notice also that some of the cloud tenancy attributes could be set outside of the code with Linux operating system variables with tf_var prefix. This will help to make your infrastructure secure as the code will not include the sensitive data. All of that makes sense, of course, only if you store your code versions in some Git repository. After Terraform providers, let's focus for a moment on the essence of the code, which is Terraform resources. Terraform resources are delivered by particular Terraform provider, and they will give us access to Cloud REST API. In HCL code, you can customize your resources configuration. Resources can be a low-level component such as physical or virtual server. It could be also some higher-level components such as databases. On the right hand on your slide, you can see three examples. First one is VCN, Basic Network Component within OCI Oracle Cloud Infrastructure. Then you have a subnet resource with some dependent resources. And finally, on the bottom, you can see OCI VM instance, also with some other dependent resources. On the next slide, you will understand that this dependency is a Terraform Interpolation. Yes, in fact, Terraform Interpolation is a fundamental element of the Terraform syntax and resources configuration. Embedded within the string with Terraform HCL or JSON syntax, you can interpolate other values, for example, other Terraform resources. Simple syntax of the interpolation is so powerful. It allows you to reference not only resources but also some other variables, even some attributes of the resources. You can also employ the functions which will do some transformations on the fly. All of that makes Terraform code so elastic and configurable. On the right side of your slide, you can see VCN and subnet, both to be created in a dependency. Subnet is nested in this VCN, and this fact is represented by VCN ID attribute of subnet, which is associated with the VCN resource. Next example is related to web server, which is connected to the subnet, right? This association is established by subnet ID attribute of compute instance. In case of Terraform configuration files, you need to remember about one more thing. Terraform Provisioner, which is commonly mistaken with Terraform Provider. Provisioner, it sounds similar to Provider, isn't it? But in reality, Provisioner play a different role than Provider. The Provider is strictly related to Cloud Vendor. In opposite, Provisioner plays a role on the resource level. In fact, Provisioner is used to execute some scripts on a local or remote machine, as a part of the resource creation or destruction. Written as a part of the code, the Provisioner can be used to bootstrap, and it can clean up the resource before destroy or even run configuration management steps within the machine created before. On the slide, on the bottom, you can see OCI instance resource called FoggyKitchen Web Server 1. After act of creation, dependent null resource is called, which is and the name of this resource is FoggyKitchen Web Server 1 HTTPD, right? And this null resource is a container for one or more provisioners. In this particular case, it will be one remote exec provisioner, and this remote exec will log into web server machine and it will execute some bash commands. When all your configuration files seems to be ready, next step is very simple. You need to run Terraform plan command. As you can see on the screen, Terraform will analyze the config file, it will build a graph of the execution, and sooner or later, you will know how many resources needs to be added, changed, or even destroyed. You can scroll up and down your Terraform output, and you can make a wise judgment if Terraform plan makes any sense to you. Maybe you don't want to change the infrastructure too much, and this plan will be, let's say, too heavy, right? Or just the opposite, maybe everything is cool and you can move forward with all this code. Keep in mind one thing. Terraform plan doesn't change anything. It is just for showing you the plan for future execution. I assume you want to move forward, right? Well, you need to execute Terraform apply command. This command will start the execution and all of the planet resources will be created. On the completion of the applies phase, you can again do some kind of analysis, which means you'll see how many resources have been created, changed, or deleted. In case of any error, Terraform will notify you and you could precisely see what has been created successfully or unsuccessfully, and you can immediately start your root cause analysis. Of course, if you want to delete resources from the cloud, there is no problem with that. Just type Terraform destroy and confirm. And that's all you need to know regarding Terraform in general. Okay, that's the end of the introduction for my course. And now we can go directly to lesson 1.